Welcome back to section 4.5. We're going to be talking about some other translations for the sine and cosine curves. So what we're going to be talking about now is shifting the graph, either shifting it left and right for C or up and down with D. So C shifts the graph left and right, D shifts the graph up and down. And I'll show you an easy way to deal with this. So now, everything else still remains the same. So let's go right to an example. Problem number 9. So looking at number 9, we're sketching this graph. So our amplitude here is 1/2. Now, the period. We do the same thing we've been doing. It's going to be 2 pi divided by now what's in front of x, and what's in front of x is 1, so our period still stays 2 pi. Our increment. That's the period divided by 4. So it's 2 pi over 4, which is pi over 2. And our interval. Here's where we're going to be talking about the left and right shift. Set what's inside the parentheses. X minus pi over 3 equal to 0. X minus pi over 3 equal to 2 pi. So you add pi over 3 to both sides. So x equals pi over 3. That would be a starting point. And then the next one would be x equals, now it's 2 pi plus pi over 3. So what that is that's 6 pi over 3 plus pi over 3 for 7 pi over 3. So for one interval, we're going from pi over 3 as our starting point to 7 pi over 3 as our next point. Now, to find the other points, there's a couple of different ways to do this. In my opinion, the easiest way to do it is by looking at your starting point, our pi over 3, and just adding our increment each time. So over here, I'm just going to do it off to the side. Pi over 3 plus pi over 2. So that's pi over 3 plus, and that's going to be 3 pi. Oh, sorry, let's try that again. We need our common denominator. So our common denominator is going to be 6. We multiply by 2 over 2 and by 3 over 3. So we get 2 pi over 6 plus 3 pi over 6, which is 5 pi over 6. Then we're going to do 5 pi over 6, and then we're going to be adding, once again, that pi over 2. And now pi over 2 is just 3 pi over 6. We're just going to be adding 3 pi over 6. So that's going to be 8 pi over 6, which we can reduce to 4 pi over 3. And then we do 8 pi over 6 plus 3 pi over 6, which is 11 pi over 6. And then we go again, 11 pi over 6 plus pi over 2, which is 3 pi over 6, which is 14 pi over 6, which is 7 pi over 3. And that's the end of our interval, so that would be enough to sketch one full period. So pi over 3. Here's my pi over 3. That's my starting point. Then I'm going to go to my next one, which would be pi over 2 apart, which would be at 5 pi over 6. Then we're going to be at 4 pi over 3. Then we're going to be at 11 pi over 6, and then 7 pi over 3. Now this is still sine, so it's going 0, max, 0, min, 0. We still follow that same pattern, except we're starting at pi over 3. So pi over 3 is our 0, max at 5 pi over 6, 0 at 4 pi over 3, negative 1 at 11 pi over 6, and then 7 pi over 3, we're back to 0. Oh, excuse me. I went too far. The amplitude is only 1/2. Sorry about that. So that's why we're not going all the way up or all the way down. And there's our graph. There's our graph. So it's all about finding the interval for our start point and end point for one period and just adding the increment each time. Looking at problem number 10, it looks a lot more complicated, but it's really the same exact thing. Now, looking at it, the amplitude is 3. The negative just means x-axis reflection. So our amplitude is 3. Now our period, we do 2 pi divided by what's in front of x, and what's in front of x is at 2 pi. So our period is 1. So for that, our increment is 1 divided by 4. So our increment is 1/4. And now for our interval. Our interval. So what we do, set what's in the parentheses, 2 pi x plus 4 pi equals 0. 2 pi x plus 4 pi equals 2 pi. And now you solve for x. Subtract 4 pi from both sides. 2 pi x equals negative 4 pi. Divide both sides by 2 pi. X equals negative 2. And then subtract 4 pi from both sides. 2 pi x equals negative 2 pi. Divide both sides by 2 pi. X equals negative 1. So now, looking at this, we're starting at negative 2. So it's negative 2 plus 1/4. That's a negative 2 over 1. So it's going to be negative 8/4 plus 1/4, which is negative 7/4. That's the next one. Negative 7/4 plus 1 over 4. Negative 6/4, which is negative 3/2. Negative 6/4 plus 1/4 is a negative 5/4. And then negative 5/4 plus 1/4 is a negative 4/4, which is negative 1. So there's our starting and end points. Now for cosine, it normally goes max, 0, min, 0, max. But we have that reflection. So what we're going to be doing is the opposite. Is the minimum, 0, maximum, 0, and then the minimum. So that's the pattern we're going to be following because of that reflection. So here we have negative 1. Then we're at negative 5/4. Then we're at negative 3/2. Negative 7. Sorry, my spacing got a little messed up. Negative 7/4. Negative 2. So now we start at the minimum. Then we're at 0. Then we're at the maximum, 0, minimum. So here is one period using that interval. And they're all spaced 1/4 apart. That's what the graph looks like. If you wanted to do another period, you just keep going. We'd be at negative 1, so it'd be a negative 3/4. Negative 1/2, my spacing is terrible, negative 1/4. So we'd be back to 0, max, zero, and then minimum at 0. Sorry, it got kind of squished over there. but you can see how we found the value. So our interval, going from -2 to -1 for one period. So there is one period between those 2 points. And let's do one more. Okay, now number 11. So you might also see this written as y equals 3 cosine of 2x plus 2. Doesn't matter if that 2 is at the front or at the end. Start with our amplitude. Our amplitude is what's in front of the cosine, which is a 3. Our period is 2 pi divided by what's in front of the x, so that's divided by 2, so our period is pi. Our increment is the period divided by 4, so it's pi over 4. And now for our interval. Our interval, set what's after the cosine, so 2x equal to 0, 2x equals 2 pi. So you get x equals 0, divide both sides by 2, you get x equals pi. That's our starting and end point for one period. So now, sketching. I know for my amplitude, or for my y-axis, I need to go at least to 5 because I have my amplitude. And now this 2, that tells us at the end we're going to go up 2. So for my y, I'm going to go from -5 to 5. And now for my x-axis. Starting at 0, then we're going to add pi over 4. So we're going to be at pi over 4. Then we're going to add another pi over 4. We're at 2 pi over 4, which is pi over 2. 3 pi over 4, and then 4 pi over 4, which is pi. Now it's cosine. Cosine of x goes maximum, 0, minimum, 0, and then to the maximum again. So we're going to start at the maximum of 3, to the 0, down to the minimum at -3, to 0, and then to the maximum. Now, before we do the rest, we want to shift our graph up 2. I'm going to use an X to go, moving my points up 2 each time. So now, when I draw my graph through this, use a different color. Now that we shifted up 2, there's our graph. And now our graph, instead of oscillating, like going up and down from the x-axis, it actually oscillates along this line, y equals 2. You can see it's the same distance. It's going to be 3 above y equals 2, and then 3 below y equals 2. And that's our graph when we shift up. We'll be doing plenty of practice on this. All right, I will see you in the next video. We're going to graph our other 3 functions: tangent, cosecant, secant, and cotangent. Thank you, and have a nice day.